Maturity Level 1 Continuous Training. The goal of Level 1 is to perform continuous training of the model by automating the machine learning pipeline. This lets you achieve continuous delivery of model prediction service. So the goal in Maturity Level 1 is to automate the machine learning pipeline, not the end-to-end pipeline that is required to deploy the final system. So what are the characteristics of Maturity Level 1? First, rapid experiment. The steps of the machine learning experiment are orchestrated in the Maturity Level 1. The transition between steps is automated, which leads to rapid iteration of experiments and better readiness to move the whole pipeline to production. Continuous training of the model in production. The model is automatically trained in production using fresh data based on live pipeline triggers. We will talk about the triggers soon. Experimental operational symmetry. The pipeline implementation that is used in the development or experiment environment is used in the pre-production and production environment as well, which is a key aspect of MLOps practice for unifying DevOps. Modularized code for components and pipelines. To construct machine learning pipelines, components need to be reusable, composable, and potentially shareable across machine learning pipelines. Containerization, for example, the use of Docker containers alongside a container orchestration system such as Kubernetes is recommended. Continuous delivery of models. A machine learning pipeline in production continuously delivers prediction services to new models that are trained on new data. The model deployment step, which serves the trained and validated model as a prediction service for online predictions, is automated. Pipeline deployment. In Level 0, you deploy a trained model as a prediction service to production. For Level 1, you deploy a whole training pipeline, which automatically runs to serve the trained model as the prediction service. There are some components in Maturity Level 1 that we need to know and understand. When you deploy your machine learning pipeline to production, one or more of the triggers automatically executes the pipeline. The pipeline expects new live data to produce a new model version trained on the latest data. Therefore, automated data validation and model validation steps are required in production. Data validation decides whether to retrain the model or stop the execution of the pipeline. Data validation checks to make sure there is no data schema skews and there is no data value skews. In data schema skew, anomalies in data appear. In data value skews, significant changes in the statistical properties of data appear. Model validation. Model validation involves producing evaluation metric values, making sure that the performance of model is consistent on various segments of data, and making sure that you test your model for deployment, including infrastructure compatibility. Feature store. Feature store is an optional additional component for the Level 1 machine learning pipeline automation. A feature store is a centralized repository where you standardize the definition, storage, and access of features for training and serving. The benefits of a feature store include discover and reuse available feature sets, serve up-to-date feature values from feature store, and avoid training serving skews by using the feature store as the data source for experimentation, continuous training, and online serving. Metadata management. In metadata management, information about each execution of the machine learning pipeline is stored in order to help with data and artifacts lineage, reproducibility, and comparisons. Information that is normally stored in metadata management includes the pipeline and component versions that were executed, the start and end date, time, and how long the pipeline took to complete each of these steps, the executor of the pipeline, the parameter arguments that were passed to the pipeline. Machine learning triggers. A trigger starts the automated process. There are different types of triggers. On demand, which is ad hoc manual execution of the pipeline. On a schedule, for example, you schedule the pipeline to be executed every midnight. On availability of new training data. On model performance degradation. On significant changes in the data distributions. If we monitor the data attributes and we notice the significant differences between the data distributions in training phase and in online or in production, then we can kick off the process again.